What is going on, team? Today we are taking on challenge 9, and challenge 9 is called King. Now, with this challenge, I did have to cheat. I'll be honest. I'll be honest with you, Internet. I had to cheat a little bit. And reason being is that I interpreted this as a reentrancy attack, which kind of is, but kind of isn't, because you can obviously see reentrancy is the next challenge. With that being stated, yeah, so I had to do a bit of cheating, but learned a lot, and I'm going to share what I learned with you. First things first is we are going to review the challenge. All right, so this challenge is based off of an actual attack, which is called King of Ether, and I'll show you that in a second. But in the challenge, you can see basically the contract below represents a very simple game. Whoever sends in an amount of ether that is larger than the current prize becomes the king. On such an event, the overthrown king gets paid the new prize, making a bit of ether on the process. So the goal of our challenge here is to basically ensure that once we become king, we stay king. And you can see that when you submit your instance back to the level is going to reclaim ownership. They're going to try to reclaim ownership. And to beat the level, we have to avoid such self-proclamation. So, in a nutshell, we have a pyramid scheme. So I'm sure you've heard of that. If not, you should Google it. Pyramid scheme, basically in simple terms, is stating that if I put in money, then somebody else puts in more money than me, and then I get paid back for the money that I put in, and then they're the king. So then somebody else puts money in, and then this person gets paid back for the money they put in, and then this person becomes king. And it's an iterative process where you keep basically trying to overdo the other person to become king of the hill or king of ether. That's the simple premises of what this is going on here. All right, with that being stated, this is our contract, which we'll review in a second. But first things first, per usual, we have to thank the handy-dandy Web3 developer blockchain dude, because he obviously helped me with this challenge with his solution, so he should get the cred there. Next thing is, here's a great image that kind of represents King of Ether. I put this image in here, so if you're a Dark Knight Batman fan, in this movie, the Joker specifically has somewhat of a psychotic focus of burning everything down to the ground, including himself. And this attack specifically, I felt encompassed that, because the way that we're going to attack this contract is we're just basically saying, F you to the world, and we're going to burn it all down, and we're going to go down with it. Because we're kind of self-sabotaging ourselves to ensure that everybody else is impacted as well. So it's a bit of kind of like a psychotic situation here, but that's the attack that we're doing. Next thing is, when doing this challenge, you need to get more ether if you, like me, only had like 0.5 in your Rinkeby testnet. So to do that, you're going to want to go to any of the faucets, but I've gone to this faucet because it's baked into the extension here for the Fox MetaMask thing. And to do that, you can just go to buy here, buy, and then you want to buy ether from the faucet. It's going to take you to this console here, and then you're just going to go to crypto faucet here. And then the trick here is basically you have to make a tweet. So you're going to go to Twitter. It's going to make a tweet for you. You're going to copy and paste your address into this tweet. So once you've done that tweet, you'll paste that URL into here from that tweet, and then it'll give you a series of ether. So I just did the largest amount, which is 18 for 3 days. That took me a bit to figure out, because I kept on just putting in the address hoping that it would send me ether, but you have to put it on your social medias first. So you need to get some ether to do this challenge. First thing, don't mess up like I did. All right, next is a few takeaways, but we will review the code before we do the takeaways. So let's go to the code. All right, as per usual, we have our compiler version here for 6.0. Remember, this shouldn't be floating, it should be fixed, and we're going to have to turn this to 8.0 when we write our contract, because Remix doesn't accept anything below that. Next, we have our contract. So our contract is labeled King, hence the concept of King of Ether. Oh, and I also promised you that I would show you that. So let's go to that. Maybe not. No, we won't. Yeah, we'll come to that later. Let's just review the code so we don't jump around too much. All right, so we have our contract called King. Now this contract has a series of state variables. And these state variables, the first one is an address, so that's going to be the king, the current king of the contract. Next one's going to be the prize. So that's basically stating what amount of value is put in by the alternative king to become king. So how much money do you have to put in to become the king, basically. And then the last one here is going to be the owner. So the owner is simply the person that's deployed the contract. Then we have our constructor, which is going to be the person that's deploying the contract. These things are going to be set. So we can see the sender, that's going to be the owner. We're going to have the king, which is going to be the sender. So the original king of the contract is going to actually be the owner, the person that's deployed it. And then lastly is the amount of value that this initiator put in place. So the person that deployed the contract, how much value did they put in there to then set like the baseline for the king. After that, we have a receive function and a king function. So the receive function, this is kind of where the action happens, right? This is where we're going to do a lot of our hacky stuff. All right, so in the receive function, it's externally payable, so that's good. And then we have this require statement here. So to send ether to this contract and become the king, we have to meet one of two criteria. And this reason I know it's one of two is because this is an or statement. So those two dashes is an or. And so we have two things. So either the value that we send has to be higher or equal to the prize to become king, or you have to be the owner. So first things first, we're definitely not going to be this right here because we've not deployed this contract, and currently there's no approach that I can see that allows that to happen. So we're going to take this tactic here. So we're going to send a certain amount of ether to become the king. Then, after we've sent this ether in, it's then going to transfer. The value we're sending to the previous king. So basically, the king that was the king prior to me, they're going to pay them off because remember how we said this is a pyramid scheme, right? So we have a pyramid. I'm going to draw some pictures here. We have a pyramid. So initially we have a king on top, and this king, say they put in 5 ETH. Well, if we put in 6 ETH, then we will become the king. So we'll become on top of this king. We'll be the king. But when I become the king, prior to me becoming king, they're going to send this 5 ether plus maybe some interest. So maybe it's 5.5. They're going to send some 5.5 to this king here. That was the recent king. And that's what's happening here, where we're going to send that 5.5 to that king so we can become king. So we've sent that off to them. And then the next thing that's going to happen is the sender, so that's going to be us because we sent this value in here, we're going to become king. So we're the new king. In addition to that, they're going to set the value of saying, okay, now the limit is 6. So if anybody puts anything above 6, then they can become king. That's the prize value. So that's that bit of code. And the last piece here is somewhat of a helper function, basically, just allowing you to know who's the king currently. So it's a public view returns an address, and it's basically returning the king. So if we call this, we're going to get back who the current king is right now. So that's our contract. And the next bit is going to be our attack. But before I do that, let's take a step back and explain what's going to happen here. So let's share the king thing first. All right. So this is the actual game and contract that was hacked historically back in the day, and that's what this challenge is based on. And I would honestly say this is required reading. I highly recommend that you take time to read through the postmortem, specifically talking about how in 2016 in February they realized that there was this weakness in the contract and it was vulnerable to this attack. And it really gives a great explanation to the issue and explains it in simple terms. So that is quite important. I recommend reading that. In addition to that, I have some notes here to kind of explain what the weakness is and some of the considerations to have as well. So one of the first things here is handling errors. A vulnerable flaw in this contract is it's unable to handle errors in a fashion that it continues execution without realizing that something errored out. So that's a big issue. And this kind of leads me to another point that I've read historically in a few different security best practice blogs associated to blockchain and Solidity more generally, is stating that trusting external parties is a no-no. And that kind of falls into the whole trustless concept, right? Where we as individuals or we as developers, when creating these contracts or whatever they are, you should ensure that you're not trusting really any input or interaction that you're having with others. You need to, verify. So verify. Don't trust but verify. That's what it is. And we're not doing that here. So we're just going to transfer some funds without validating what's come back and taking action on what that response is. That's another weakness here. And another thing here is that we're using transfer. So you'll see in a lot of security recommendations currently that the quote-unquote best practice is to either use send or transfer because that prevents the reentrancy attack, which is going to be the next challenge. But like I've stated in these notes that I've written out for myself, this is quickly falling out of falling out of trend. People are stating not to do that. Reason being is that this there's a false assumption baked into using this. And the reason that people use send and transfer and they do it to prevent reentrancy is because there's a limit of gas that's sent with that transaction. So when you send a transaction to somebody, you're sending not just the ETH that you want to send or the message data you want to send, but you're also sending in excess of 2,300 gas to complete that execution and that transaction inside of that contract, because there's a certain amount of gas needed for that code to do what it needs to do inside of that contract. And they're hoping that this 2,300 limits it from having that reentrancy attack where it keeps going on to itself. But with this being stated, there's two good links here that I'll share with you stating that the current gas establishment of how much is sent and how much is needed for certain call codes, opcodes, kind of in the EVM, that is going to increase over time. And you should kind of bake that into your development, knowing that the gas usage and need for certain opcodes will increase over time, and when that does, you can't rely on this gas limit to do the things you need it to do. So instead, you should utilize the call function or the call method instead, because when using this, there is no limit. So you're sending out the gas and you're sending out an excess, and it's basically there is no gas limit that you're sending on the execution. And instead of relying on the gas limit to protect you from reentrancy, you should instead use the check effect interact pattern that we've discussed historically. And if I show you these two links, I'd recommend reading them as well. So this is top security best practices for DeFi. Inside of here, you can see this section here basically stating that there's a maximum gas usage for transfer and send, but when it comes to call, when it forwards it to forwards all the gas next to the next contract. So there's no set limit. So that's kind of what they're making here. And then also there's another link here that I've linked in my notes, which goes to this blog here from Diligence, which is a consensus security auditing firm, and they specifically talk through how you shouldn't utilize transfer anymore, and that encompasses send as well. And they state that you should use call instead. And instead of you could do both the check effect interact pattern, or you could use mutexes, which they talk through here as well, which are basically modifiers you can put on contracts that lock the function as it's going, and that could be a separate conversation, but just know there are different methods to actually secure yourself here. All right, back to the notes. So we've talked through this, and we've talked through this. So now what we're going to do is I'm going to review the attack contract, and I'm specifically going to walk you through what's happening here, and then we'll actually do the attack. So it's very straightforward, very simple, and very short. So we have our compiler, 8.0, and we have our contract here called attack. And this contract, we have a constructor, which is a common thing you'll see with a lot of the stuff that we're doing. So we need to put in an address so when we deploy this, so we know what we're attacking in this contract. So we're going to put in the king address for the challenge that we're going to attack. This is going to be publicly payable because we want to put Ether inside of this so we can exceed the prize limit. So remember how we kind of in our analogy, we had the prize limit of 5 and we wanted to send 6 to exceed that. Well, that's what we're going to put here. So inside of here, we're basically going to say this address is what I want to call to, which is what we put in here in our constructor. That's what we're deploying to. We're going to run a call method, and then we're going to put in a value here, and that message value is going to be the Ether 6 that we want to put in there. And then we're putting these double quotes in here because this is something we've talked about in previous challenges, but inside of this call method, when you're sending Ether to someone, you need to include these parentheses and these double quotes, which basically states that I'm not calling a specific function that I know of, or really it's going to be the first 4 bytes of a function that's hashed. So we're not calling anything specific, we're just sending it in general. So when you send something in general with the remaining gas, that's usually going to fall under a fallback function for the contract we're sending it to, or it's going to hit a receive function, which is going to receive the Ether fallback. So these are one of the 2 locations this is going to hit when we send it. So that's that bit. And then we have our fallback. And this is going to come into play, I'll explain in a second, but this fallback is basically an external payable, and we're going to revert, and we're just going to include a revert here that's going to say pickle Rick. This doesn't really matter. You could have this blank if you wanted to, and it could just be a revert without anything, but I enjoy Rick and Morty, so I wanted to put it in there. So that is our attack code. Now what's happening here? let's go back to the contract and walk through specifically how this attack is going to occur and how we can kind of watch it unfold. So we're going to draw this into two paths, right? So there's going to be, step one, and then there's going to be step two. So step one is we're going to send our ether to this contract to become king. And when we do that, we're going to send our ether here. And remember that we're sending it without a specific function, so it's going to hit receive because that's what's going to catch it. There is no fallback here, so receive is going to catch that. It's external payable, so it will take our ether. And what we're going to send here is we're going to send 6. And let's just say that the current prize here is 5. And the current king is whoever that is. So we're going to send 6 here, and we're going to pass this require statement, which is great. Okay. After that, they're going to send the remaining value to the old king. So they're going to send the 5, say 5.5, back to the old king. And then after that, after they've sent the 5.5 back to the old king, we're going to become king because we're the sender. So we're now the king, which is great. And the prize that we've set is 6. So congratulations, we've done that. So after that, now the next thing here is when we submit our instance, we need to ensure that the challenge isn't able to take king back from us. Now that's where the fallback comes into play with the revert. So as soon as we submit the instance, in step 2, the challenge is going to try to take king back from us. And when they do that, they're going to try to send in ether that's higher than ours. And then what's going to happen here, this is where all the magic happens here, is this transfer. So this transfer here is going to try to send us back our 6 plus interest. So we'll say 6.5. And when it tries to send this 6.5 back to us, in our fallback function, we don't have a way to receive that ether. We've not set up a receive function, and we've not set up any of that stuff. In addition to that, there's a gas limitation. So the original King of Ether contract challenge, they assumed that they were sending it to only externally owned accounts. And they didn't think they were sending it to contracts. But remember, when you send something to a contract, there's some sort of amount of execution that has to occur with that code set to do something. Now, when they're sending this to us, they don't realize they're sending it to a contract, so that 2300 limit that we have on this transfer could be exceeded. And when it's exceeded, that could revert this transaction to a failure. And that's kind of what's going to happen with us. And we're going to artificially create that with our revert that we've put in there. So we've put a revert in our contract. Remember when it says our pickle Rick here. And when it tries to send this value back to us, we're going to revert. And when we revert, we're going to send back a failure. But when we send back this failure, this contract has no way to actually validate what's been sent back because it automatically assumes and it bakes in an assumption that we're going to correctly accept the ether and keep moving on. And that's when it comes to the point that I made earlier where you shouldn't necessarily trust anything when it comes to the input or response from any external party you're interacting with, either contract or human. You need to validate all of that. And there's no validation occurring here. So when we send this failure back, it's just going to keep going. And it's going to act as if we've accepted the ether, but we really haven't. And it's going to keep going, and it's going to set the sender, and it's going to set the value and all that stuff. But in the end, none of this will be set because we've erred out. So there's no way for the next king to have an establishment of who the king is and the prize value is because we've reverted back that failure. And so I hope that kind of makes sense because I do my best to explain it. If you can't, go check out the other YouTubers. But yeah, so that's the challenge. That's the code review. And let's actually solve the challenge together. All right, so we have our contract here. And if we open this up, open up our console. I've already got my instance, so you'll want to do that. So if we do contract, first we'll look at the prize. And in here, if we open this up, we'll see that the current prize is going to be this number here. And I pulled up Web3 utils because I wanted to figure out what that large number was in Ethereum. So I wanted to, because I know this is in Way. It's the lowest common denominator or currency value, whatever, that they use. And I wanted to understand what that was in Way, so I knew how much Ether I needed to send. It's super low, so you really just go to 1 ETH. But I wanted to kind of utilize this more to learn how to use it for purposes. So if we just copy and paste this here, we're going to put that there. And then I'm going to copy and paste this value here. And we're going to go from way to ether. And we can see this is the amount of Ethereum that we have. So that's, amount of Ethereum, and that's super duper low, so we can just send one. All right, with that being said, I have my attack set up here. And what I want to do is I want to deploy this to the attack contract, or the contract we're going to attack, which is going to be this. And this is the address of the contract that we're attacking here, which is king. So we have our attack, we have inject web 3 set up, and now we want to bump this to 1 ether. And when we deploy this, oh, and also you can see my revert doesn't say anything in it, it's just empty. We could add stuff in there, but it doesn't really matter. All right, cool. So we can see that this has successfully gone through, and I've not showed you the king previously, so sorry about that. But if we look at king now, we can see that it's 0x E9CE. And if we go here, we can see that our contract is 0x E9CE. So we can see that we're currently the king because the contract is the sender, and that's kind of who we've established as the king currently because we sent in more ETH. Now, if we submit our instance, we should maintain ownership of this and remain the king. And this kind of goes back to the point I just made. So in here, as we talk through step 1, we've sent ETH in. We've done that part, right? So we've sent our ETH in, and we've become king down here. Now the next step, this is currently processing. The challenge is trying to take this back over from us. But since we're sending back a failure here instead of a success, then this shouldn't continue, and we should remain the king. So if we go back here, we can see that it's done, and we won. And it points you to basically the postmortem that I told you to read, and also the challenge of this, what this is based on. And that's the challenge. So internet, we've completed king. Now we're on to re-entrancy.